students, let us move on to the next topic, that is determination of minimum expressions using essential prime implicants. So here you are going to determine the minimum expressions using essential prime implicants. So first let us see what is an implicant. You have to know what is an implicant. So any single one or any group of ones which can be combined together on a map of function f represents the product term which is called an implicant of f. So you know this implicant is formed by the K map itself. Okay, so you have to look into the K map and you have to see which any group you have or any single one you have which can be combined together in the map. Okay, so that term we call it as the implicant of f. So that is the definition. Any single one or any group of ones which can be combined together on a map of the function f represents a product term which is called an implicant of f. So now let us see what is a prime implicant. A product term implicant is called a prime implicant if it cannot be combined with any other term to eliminate a variable. So if you have a K map and if you are looking into the K map and you are going to encircle the some of the ones in the K map, is it? So when you are combining all these ones, you get a product term. Finally, you will be getting some product term, maybe A bar, B bar, C or A C bar. So such terms you will be getting using when you are going to encircle the K map. So there such terms when you are getting the product term, we finally get the product term, is it? So such terms which cannot be combined with any other term to eliminate a variable. That means you cannot combine those product terms with any other ones, nearest ones, okay, to eliminate a variable. So you cannot reduce that later, okay. So it is all fixed, you say, okay. So that term we call is as a prime implicant. So these are the two definitions, implicant and prime implicant. So now let us take one particular example to show which are implicants or prime implicants and which are not prime implicants. So here in the figure, let us take this particular K map, and you have it is a 4 variable K map, A, B, C, D you have. So here already you can see that there are some ones which are already grouped. Okay, see here in the figure A bar, B bar, C and A bar, C, D bar and A, C bar. That means which are the terms? Let us see that A bar, B bar, C is this. Okay, that means you have encircled one the pair here, is it? So you have got the product term, that is A bar, B bar, C. So this term and A bar, C, D bar, that means this is another term, product term. So here this term and also the quad you have here, that is A, C bar, is we call it as all these three terms are prime implicants, okay, because they cannot be combined with any other term term to eliminate a variable. So you can see that whether this pair whatever you have encircled, can it be combined with any other term, nearest term? It cannot be combined. Only possibility is you can combine one in this way and you get the final term as A, B bar, C, okay. Again you cannot reduce this particular expression, is it? So same way here A bar, C, D bar, that is the expression you got from pairing these ones here. So that this term also cannot be combined to any other nearest terms to reduce the variables, is it? So same way another term what you can see here is when you are encircling the quad in this manner, you finally get the expression as AC bar. Okay, AC bar. So this quad also you cannot combine with any other term to eliminate a variable. Okay, you cannot reduce this product further. So we conclude that the three terms over in this particular problem are prime implicant. And also you can see that you may be thinking here why they have encircled these pairs also inside. They are also implicants. Okay. So here to show that particularly neither A B C bar nor A B bar C is a prime implicant because these terms cannot be combined together to form A C bar. Okay. So this is usually you don't encircle in this manner. Okay. Pairing we don't use if we have adjacent ones in this manner. Okay, because four ones are all together. So this is not this is not a prime implicant. One or here one you have. This is not a prime implicant because these terms cannot be combined together to form A C1. AC bar. Okay, so that's why we finally conclude that the major prime implicant over here is AC bar. Okay, so another term you can see here which is left out without answer click. So A bar, B bar, C bar, D bar. This term. It is not a prime implicant because it cannot be combined with it can be combined with A bar, B bar, C, D bar and also A, B bar, C bar, D bar. That means this one can be combined either with this one or this one. Is it? So that's why it is there are two possibilities here for combining this one here. Is it? So you may be thinking whether to combine with this one or this one. So we conclude that this term, that is particularly A bar, B bar, C bar, D bar is not a prime implicant. So now let us see how to find a prime implicant from a K-map. The first rule is a single one on a map represents a prime implicant if it is not adjacent to any other ones. Okay, so in the previous example I have shown in the previous slide, so there you can see that there was one single one, is it? But that one was not a prime implicant. We have concluded that one is not a prime implicant because it can be combined with adjacent ones. There were two possibilities that that particular one can be combined with other two ones. So we have concluded that that one is not a prime implicant. But here, if you want to have a prime implicant, it say that the rule is a single one on a map represents a prime implicant if it is not adjacent to any other ones. Okay, it should be a single one, isolated one, then only we can say that it is a prime implicant. And next thing is you have to remember is two adjacent ones on a map form a prime implicant if they are not contained in a group of four ones. Okay, so that means if you think that you had two adjacent ones, that means in previous slide only if you are seeing there were two adjacent ones like A B bar C bar and A B C bar was the two pairs you found inside a quad itself. So that A B bar C bar and A B C bar we have concluded that it is not a prime implicant since it was present inside a quad. Okay. So same way here this thing is rule is two adjacent ones on a map form a prime implicant. So when it can be a prime implicant, two adjacent ones. Okay, two adjacent ones means it is a pair. Okay, a pair can be a prime implicant if they are not contained in a group of four ones. Okay, the next rule is four adjacent ones form a prime implicant if they are not contained in a group of eight ones. Okay, that means four adjacent ones means you have a quad, but that quad should not be contained in a octet. Okay, so then it can be concluded as it is prime implicant. So next rule is a minimum sum of products expression for a function consists of sum of the prime implicants of a function. So think that you have a K map and you have identified the prime implicants, so many prime implicants you may be getting from the K map. Okay, you may encircle in different manners and you get so many prime implicants. Okay, so that time when you are forming a minimum solution, finally you have to form a minimum solution, is it? So that minimum solution may contain few prime implicants. Okay, not all, not necessarily all, it may contain few prime implicants which you are going to select. Okay, in other words, a sum of products expression containing a term which is not a prime implicant cannot be minimum. So if you have included a non-prime implicant in the expression, so that expression we are going to consider as, we are not going to consider it as a final expression because it is not minimum expression. So fine, the main aim is you have to get a minimum expression. Okay, finalize. And so here the heading itself says that determination of minimum expressions using essential prime implicant. So that means you are going to form the minimum expression. Maybe we say f. F is a final uh, function. You have f is equal to a bar b bar d plus b c bar plus ac. So like this expression you may be getting. So this expression will be containing some of the prime implicants. Okay, so this is true because if a non-prime implicant or the non-prime term were present, the expression could be simplified by combining the non-prime term with additional mean terms. So as you have seen in the previous slide, you have seen a particular non-prime term that was at the top right corner you had a single one, is it? So there that non-prime term was able to combine with two other adjacent ones, is it? So so by seeing that only you can understand that, so if a non-prime term is included in the expression, so there are possibility that it can be further simplified. Okay, because that non-prime term can be combined with some of the other adjacent ones also. Okay, so that is one more rule you have to follow here. So now let us take one particular problem to see the prime implicants. So what are the possibilities of prime implicants in the K-map? So let's take this particular example. You can see the example here. So the first rule is you have to find the largest group. So what we have done is first we may try to encircle the quad. Okay, you have found 4 ones, so you have encircled the quad, and same way another quad you find and you try to encircle, and two ones you have here, that also you are going to encircle. So you have got initially three prime implicants, and there are some other prime implicants also. So suppose you have combined two pairs here, is it? This pair cannot be combined with other, so that's we have done this way. Okay, and also you can see that there is rolling of map, so this one can be combined with this, so that also we are going to combine, and we have formed a expression that is p bar cd, and another quad. So this all dashed one you have, is it? And circle in dash, so they are also the prime implicants. So here in this particular problem, three of these prime implicants cover all the ones on the map, and minimum solution is the sum of these three prime implicants. So you have how many? 1, 2, 3, 4, 5, 6. Totally 6 prime implicants in this problem. Out of this, three are three are the prime implicants we are going to choose to form a minimum solution. Okay, so that is here this, that is a bar, c bar d, and um, which one is that, b c bar and ac. Okay, so that they are the prime implicants we are going to choose to form a minimum solution. So the shaded loops represent prime implicants which are not part of the minimum solution. So you also have some other prime implicants in this problem, but they are not the they are not the prime implicants which has to be included in the minimum solution. We have seen a previous example where you had contained 6 prime implicants, out of which you have chosen 3 prime implicants to form a minimum solution. So all the prime implicants of a function generally need not be in the minimum sum of products. A systematic procedure for selecting the prime implicants is it's needed. Okay, so if prime implicants are selected from the map in the wrong order, a non-minimum solution may result. So if you are going to select the prime implicants in a wrong order, okay, think that you have selected all the 6 prime implicants and you have formed a minimum solution, then your problem may be wrong. Okay, so there are some certain rules or systematic procedure that has to be followed while selecting the prime implicants also. Okay, then only you will be getting the minimum expression. So let us take one more problem to solve the expression, minimum expression using essential prime implicant. So in this problem you will be knowing what is the essential prime implicant. So why you need that. So here consider the first problem here. So here for example in the figure, if CD is chosen first, then BD, B bar C and AC are needed to cover the remaining ones and the solution contains four terms. So what they are saying is, suppose you have started to solve the particular problem. Here they have given the what is that, from the table you have drawn a K map, and here A, B, C, D is a variable you have shown. Okay, and you are trying to encircle now. You start encircling. So you think that you have chosen, you see initially you see 4 ones here, so you have encircled this. Okay, so remaining ones you have here. So what you will be doing, the next step you will be doing, you will try to encircle this. Okay, so the rolling of map you will be doing this way, you will do, and here this, and next you will be encircling this. So you think that all ones are covered. So finally means we have to cover all ones. So you start writing the expression now. F is equal to, so what is this first encircle thing we have, that is CD. Okay, so it's write CD, and next you have BD, okay, BD and B bar C and also AC. So there are 4 quads you have encircled, so that's why you get 4 uh, 4 terms here. That's it. Finally you get 4 terms. So think that another student or your friend is going to solve the same problem in a different manner, and he is not going to encircle the CD initially. What he will be doing, he has a quad here. Okay, he have covered one. Okay, he started to do the problem, and also here remaining ones he had, so that's why he tried to do here this manner. And also the next thing is he has covered the other ones, and he had formed the expression F is equal to BD B bar C plus AC. So now which one is right? Here you have got only 3 terms finally. One, that is here BD, B bar C and AC. So CD is not included here because all ones are covered, already covered, so we have not included that. So if the prime implicants indicated in the figure B are chosen first, all the ones are covered and CD is not included. So here, whatever you have encircled, all are prime implicants. Is it? They are essential. It's not essential prime implicants. They are only the prime implicants using. Okay, here. And CD is also a prime implicant, but it's not included in the final expression. So this is a case here. So let us try to sort out what is the solution. First is best solution here. Now let us see the procedure that has to be followed when you are finding the minimum solutions for the function. So note that some of the mean terms on the map of the figure A can be covered by only single prime implicant, but other mean terms can be covered by two different prime implicants. For example, here if you are going to see M2 is covered by B bar C. So let us see it is B bar C and CD and all. I'll plot that here. If you're writing the expression, this is actually the encircled quad. Here is BD. Okay. Next you have this quad. Okay. That is AC. And next you have one more quad, that is we write it as B bar C. Okay, this is CD. That is this one. Okay, this is CD. Here now if you are seeing the mean term position 0 will be here, 1 second mean term position, the third mean term position is here. Okay. Here what they are saying, for example, M2 is covered, so note that M2 is covered only by B bar C. M2, that is this particular term, if you are considering, that is covered only by B bar C, and M3 is covered by both B bar C and CD. Okay, so that is the key note you have to look into here. So that's why B bar C, okay, B bar C is included only in one single prime implicant. Is it? If you are looking into M2, mean term 2, that is included only in one single prime implicant, that is B bar C. So that's why we consider it as an essential prime implicant. Okay, whereas this particular one, okay, which is included with both this expression as well as the other CD expression. Okay, similarly, if you are seeing this one, okay, it is included for both BD as well as the CD. If you are seeing this one, that is included for both BD as well as AC. And also if you see one, this last one, that is also included for both AC and the other CD. Okay, so that's why this finally this term here all ones that was present in the quad is all included in other expressions. It means it is combined with uh, other terms. Okay, so that's why we leave it. We don't include this thing. Okay, only thing is which one is not included. So I will just shade that area. Okay, just shade that area which is considered. So this one which is included for only one single this, and if you see this particular thing here, this is also, this one is also included only for uh, one BD, is it? This BD term. And next thing is, if you are saying here, this one, it's also included for AC. So that's why B bar C, BD and AC is included in the final expression. That is how you find the essential prime implicant and you form the final answer. F is equal to, so if a mean term is covered by only a prime implicant, that mean implicant is said to be essential prime implicant, and it must be included in the minimum sum of products. So that's what we have done in the previous slide. If you have seen that particular problem, okay, you found there were certain prime implicants. I will share that uh, which are the things you have to include. That's here If a mean term, so this is a mean term, M2 is covered by only one prime implicant, is it? So one prime implicant, is it? So that prime implicant is said to be essential prime implicant. So since M2 is covered by this prime implicant, we conclude that it is one of the essential prime implicant. And here this M5, M5 if you are saying, M5 is also included in only one single prime implicant. So that's why this complete thing becomes essential prime implicant. So similarly, M14 is another mean term which is included in only one single prime implicant. So that's why it's also considered as the essential prime implicant. So here B bar C is an essential prime implicant. It is that B bar C. So this you have rolled map, is it? So that's why you got in the corners. So that is B bar C is an essential prime implicant because M2 is not covered by any other prime implicant. So CD is not an essential prime implicant because each of the ones in the CD can be covered by another prime implicant. So only prime implicant which covers M5 is BD. Okay, M5 is this one. So that is covered by BD. So BD is also essential prime implicant. And next thing is AC is also a essential prime implicant because no other prime implicant covers M14. So that is finally you find only BD, B bar C and AC as essential prime implicants. So these essential prime implicants are included in the final expression. So take a note here to find the determination of minimum expressions using essential prime implicants. So in general what you have to do is in order to find the minimum sum of products from a map, we should first look all the essential prime implicants. Okay, so first rule is you have to find the essential prime implicants and start encircling those essential prime implicants. So one way of finding the essential prime implicant on a map is simply to look out at each one on the map that has not already been covered and check to see how many prime implicants cover that one. So that is what we have done in the previous slide. So you had M2 mean terms, so that mean terms are not covered by any other prime implicant. That's why we concluded that this is a very essential prime implicant. That is the step. If there is only one prime implicant which covers the one, that prime implicant is essential. Okay? That is the conclusion thing. If there are two or more prime implicants which cover the one, we cannot say whether the prime implicant is essential or not without checking the other mean term. That is what if you have a single one which is covered by two or more prime implicant, then you cannot conclude that it is an essential prime implicant. So that is the thing is the conclusion here is what you have to see is you have to see the mean terms. Okay, see that mean term is covered by only one single prime implicant, then conclude that that is an essential prime implicant. Let us take one more example that was solved earlier. So here also let us see how we have found the minimum solution. Okay. So for example, in the figure M4, so we have to identify which is M4 there. So 1, 2, 3, 4, 0, 1, 2, 3, 4. Mean term 4. So this, if you are seeing, and also M10. M10 is here. The mean term 10. Okay. So this is covered by the prime implicant, is it? So you have a prime implicant here. So this mean term is covered by only one single prime implicant. So similarly, this mean term, that is M10, is also covered by one single prime implicant. Okay, so we conclude that there are two essential prime implicants. So all other ones on the map, if you see, are covered by two prime implicants. Therefore, the only essential prime implicants are B, C bar and AC. So finally, there are many number of prime implicants. You see here, there are number of prime implicants, but essential prime implicant is only two out of this. That is B, C bar and AC. So this B, C bar and AC has to be included in the final expression. Okay, you cannot reject that. And the other thing, after encircling this essential prime implicant, so we had a procedure for writing the minimum solutions. So there, what was the first step? You have to identify the essential prime implicant and you have to start encircling. So that's what, if you see this one and you start encircling here, what you will be doing, this thing you will be doing, and next start encircling this way, and two more ones are remaining, so that's why you will be encircling the other thing. Okay, maybe like this you may encircle and you may find the solution. Okay, so that's why this BC bar and AC are the essential prime implicants. Essential